Okay, so we talked about the notation and the graphs that go with inequalities. I want to jump back into reminding you about the solving. So those inequalities, you could think about them as already solved, or the solutions were obvious, hopefully. When you look at x is less than 7, hopefully that's obvious to you what that is talking about. All x is smaller than 7. But when you mix it up a little and write 3x plus 7 is greater than -5, it's a little less obvious what x's make that true. So these we will try and solve. And the big thing here is the properties of inequalities are really similar to equality, but there is a difference. So same is the fact that you can add or subtract anything on both sides without changing the solutions. You can also multiply or divide both sides by any positive number without changing your solutions. So far we're matching up with equations. The difference comes in multiplying or dividing by negative numbers. Neither one allows you to multiply or divide by 0 because you lose all information. But if you multiply an inequality by a negative number or divide, it's going to switch the direction. And I don't know, this might make it more confusing instead of less. But the way I think about that is if you think about, let's say, x equals 2. Remember that negative really means opposite. So by multiplying that by -1, what you're doing is flipping it across over the origin, over x equals 0. My pen is really giving me trouble tonight. Okay, so in that sense, whenever you multiply or divide by negative, everything is going to flip over the origin. So that means the direction of your inequality will also change. Things that were further to the right when you flip will be further to the left, so less and greater will switch. Okay, so let's go ahead and walk through. So mostly I hope this is really easy, but you have to remember, and it's the only thing you have to remember about inequalities, multiplying or dividing by negative number changes their direction. So let's see what we've got. For this first one, we have 1x on one side. It's multiplied by 3, and then we add 7. So we'll start by subtracting 7. And I get 3x is greater than -12. Next, I'll divide by 3. I'm hitting all my properties correctly, so I don't have to flip. I divided by a positive number, not a negative number. It doesn't matter if the number on the other side is positive or negative. It matters what you multiply and divide by. So to graph this thing, we're going to say, okay, we're starting at -4. We don't want to include it, so we'll go open circle. And then we want x greater than that, so everything to the right. So just like this is fine. It's also fine to give me the interval version of this. So we would say starting at -4, we go all the way to infinity without including either. So I don't care which of those you give me. If I really want to see what one notation, I'll tell you. But in general, I don't care which one, as long as you can use one correctly and you can read either of them. Okay, second one here. I only have one w. What I see happening to it is a multiply by 2 and add 6, a multiply by -1, and an add 7. So let's start by subtracting the 7. And I get -2w plus 6 less than or equal to -1. The next thing I'm going to do is divide by -1. That is, dividing by a negative, going to switch the direction. So if we want the opposite of 2w plus 6 to be less than or equal to the opposite of 1, then we need 2w plus 6 to be bigger than +1. Again, just think about switching directions from the negative sign, flip over to the positive side, and that's going to change what's bigger and what's smaller. Next, I need to subtract 6. So 2w greater than or equal to -5. And last, I need to divide by 2. So w greater than or equal to -5/2. Okay, so here's my 0 in the middle. We go negative. 1, -2, and we're looking for -2.5. So we're going to give a closed circle on -2.5. Normally I'd say leave that as a fraction, but that is exact, so it is okay to switch that one. Do make sure you label really clearly if it's between tick marks. And then I want everything bigger than that, so I'm going to go this direction. And these are all possible W's, and I've shaded off the ones that actually make the statement true. In interval notation, we would say I started at -5/2. I want to include that, and then I go forever to infinity. Okay, let's see. So you should see some in the mix that get a little bit messier. I'm thinking these, kind of like in the equations, are supposed to have a specific point, and hopefully I succeeded in making that point this time. So we'll check it out. Okay, so I have b's on both sides. So I'm going to go ahead and try and free them from parentheses. So I'll distribute that -2. I get 3b minus 2b minus 8 is less than 3 minus 8b minus 8. And then I can combine some like terms. So I get a b minus 8 is less than 3 minus 8, -5 minus 8b. Okay, so b's are no longer trapped, but they are on both sides. So I'm going to move them to the left by adding 8b, which will give me 9b's on the left, minus 8, and only a -5 on the right. Finally, down to a single b on one side, which is getting multiplied by 9, and then I subtract 8. So the first thing I need to get rid of is the 8 by adding 9b less than 3. The next thing I need to get rid of is the 9 by dividing. So I get that b is less than 1/3. And when I go and I put that on my number line, I'm going to say 0, 1. Here's 1/3 in the middle, third, and I give it an open circle to show that it's strictly less, and then I shade everything less than that, so to the left. In interval notation, that would be -infinity to 1/3, and both get round brackets. Okay, so nothing too weird in that one. Let's see if I made something clever happen in this next one. Okay, so now I see, let's see, more distribute that needs to happen. So I have 4b plus 3 times 2 minus 6 plus 2b is greater than or equal to -12 plus 10b. Ah, don't jump. Okay. I think I'm going to go ahead and distribute even though there's 3 terms. Save me from rewriting one time. So I see 4b plus 6 minus 18 plus 6b. Multiply everything by 3. And that's still greater than or equal to -12 plus 10b. Okay, so when I combine like terms, I'm going to get 4b plus 6b is 10b. And I'm going to get 6 minus 18 is -12. -12 plus 10b. Okay, so I do think something interesting is happening. When you go to move your b's to one side, they're all going to drop out, which means we're getting one of those situations where the value of b doesn't actually determine whether this is true or false. It just patently is true or false all the time. So the way you decide which it is just by looking at what you ended up with. Is it true that -12 is less than or equal to -12? And the answer is yes, that's a true statement. You don't have to write true, but that's what I'm checking out. If it's a true statement, that means no matter what b you choose, it's always true. So this is one of those where you'll say infinitely many solutions. or you can say all real numbers would work for that one. Whatever b value you choose, you'll have a true statement. So that can happen with inequalities just like it can happen with equations. And if I made this up carefully, I think the other thing can happen as well, and we'll see it here. So we start off similarly. I'm going to distribute working my way inside out, and then on the right, I just have the one set. So 4b plus 3 times 2 minus 6 plus 2b is greater than or equal to negative 14 plus 10b. And then I'm going to distribute again, and I'm going to say 4b plus 6 minus 18 plus 6b is greater than or equal to negative 14 plus 10b. So I think I have the exact same thing on the left. 10b, this is supposed to be a 6, not a bb. Minus 12 is greater than or equal to negative 14 plus 10b. And when we go to move our b's to the same side, they drop out completely, and I end up with negative 12 greater than or equal to negative 14. Okay, so maybe I didn't quite make it happen. Which is, again, a true statement. I think I was going for a false statement, but negative 12 really is bigger. So let's go back to my beginning and just pretend. So this would be another all real numbers or infinitely many solutions. What I was trying to show you is if this was going the other direction, you can also end up with a statement that's false, just like with the equations. Regardless of the value of b, it is never true that negative 12 is less than or equal to negative 14. Negative 14 is the smaller of the two. So this has no solutions. So that can happen with inequalities just like it can happen with equations. Okay, so hopefully that gives you a pretty good start. Again, just remember the multiply divide by a negative number flips the direction. That's the big thing. Thanks for watching.